Hello, how are you doing around the world? Today's tutorial is going to be about sorting an array. We're going to use 9 methods of sorting. The first one is bubble, then insertion, then selection, and these 3 methods of sorting are so common, so we're going to take them also in a recursion way. So we're going to take the bubble sort, and then bubble sort in recursion, insertion recursion, and selection recursion. Now we're gonna get to know odd and event sorting, and after that we're gonna discuss the merge sort and the quick sort. So this part is we're gonna start with the bubble sort. Okay, so as you see here, I'm opening Visual Studio Code. On the right there is the terminal where we're gonna execute our code, and in the center is gonna be the code. On the left it is the explorer part with the folder that I created called sort arrays funcs, and inside of here I'm gonna create the first file with extension of C or C++, because we're gonna apply this sorting method in C and C++ language. Okay, so we're gonna start with the bubble sort. So o1 underscore bubble dot c. Alright, so here we're gonna start just with the syntax. If you don't know anything about C language, I really recommend you to get to the description. I've created a course of C language where I covered everything that you really need to know about this beautiful language. Okay, so the bubble sort. So here inside the main function, I'm gonna just define an array. So int array. Okay, I'm gonna pass array of elements equal to 20 elements. I'm gonna just pass them here. For instance, I'm gonna take some random numbers like 1, 5, -6, -1, 18, 45, and 2. I'll duplicate the numbers 3, 4, and 19. Okay. Also, I'm gonna create the size, calculate the size of this array. I'm gonna use the size of function. If you don't know these functions, go back to the course that I've created about C, and you're gonna find everything explained well there. So I'm gonna pass here the array, and divider on the size of array at any position. Better take position 0. Alright. So I'm gonna print some message like array before sorting, and I'm gonna pass in a function that displays me the array. So it has 2 parameters, the array and the size of the array, and I'm gonna pass here the name of the function or the name of the sort that I'm gonna use. So let me make this a bit smaller. So here I'm gonna start with the bubble sort, so I'm gonna call the bubble sort, and also it's gonna has 2 parameters. It's gonna has the array and the size of the array. After that, I'm gonna print here array after sorting. And again we're gonna display the array with the 2 parameters, array and size of the array. So now we're good. So better here to catch these 3 functions here, or 2 functions. I'm gonna go at the top. I'm gonna define them here. So better to type it here like this. So both of them is gonna have a void type, and here int, and also here is gonna be array. So to display the array, we already have seen this on in the tutorial about C language, how to print an array of elements. So for int up to the size, what you're gonna do, we're gonna print the array elements. So print array elements like this, array position I. So we are now good to run this code. So if we just return 0 for instance here and run the code, it's gonna display me. So return let me clear this. It's gonna return for me, as you see here, the numbers, array before sorting and array after sorting. Of course, the array after sorting, we didn't use anything inside this function. Bubble sort is still empty, it returns nothing. So now we're gonna start in bubble sort, okay? So first you have to know what is a bubble sort, how it works. Now I'm gonna leave you with a little video to understand how this bubble sort works, okay? In the name of Allah, we're going to start explaining the first algorithm that we have here, and it is the bubble sort. So the bubble sort is the simplest sorting algorithm that works by repeatedly swapping the adjacent elements if they are in the wrong order. This algorithm is not suitable for large data sets, as its average and worst case time complexity is quite high. How bubble sort works. So as you see on the screen, there is this bubble sorting table where there is a lot of paths here. So the first pass and second pass and third pass. In the first pass we have this table or this array that has 5 elements, 5, 1, 4, 2, 8. So as you see here, what we're going to do at the first table, we're going to compare the first element with the second element, or the first element with the next element. So in this case we have 5 in the first element, then we have 1 in the second element, or in the second position basically. We have here, or we see that the 1 is already greater than the 5. So what we're going to do, we're going to swap these two elements, okay, using the swapping function. Alright, after swapping 5 with the 1 in the second table, in the first pass we have 1, 5. Then we're going to compare the third position with the second position, so that basically like comparing 4 with the 5, and we have 4 is smaller than the 5, so we're going to swap again or use the function swap. So in the first pass, the third table, we're going to get 1, 4, 5, and then we're going to compare 2 with the third, or compare with the previous element, and it is 5. And also in this case we're going to find that the 2 is smaller than the 5, so we need again to swap it. In the fourth table, in the first pass, we have 1, 4, 2, 5, 8, and at the last index, or at the last element, we have the greater element between these two. So 5 is smaller than the 8, so the table is going to be the same and nothing is going to be changed, okay? Now we're going to move on to the second pass, and that's by comparing the second element with the previous element. So again, 4, it is smaller, it is greater than 1, nothing is going to be touched in the table, so it's going to be the same. Now moving to the second table in the second pass, so we compare it again, 2 with the 4, and 2 is smaller with the 4, so we're going to swap using swap function. So we're going to get 1, 2, 4, and then we're going to compare 4 with the 5. So here no swap, because 5 is already greater than the 4 and 4 is already smaller than the 5, so no need to change anything. The same thing for the fourth table in the second pass, and the same thing for the last table. So the third pass, again, we're going to compare 4 with the 5. 4 with the 5, it is in its position. 5 with the 8, also with its position, so nothing gonna be changed at the third pass, and we've sorted the array. So this is the bubble sort, how it works. I hope you understand and get the idea. I hope you understand well how the bubble sort works. Now we're gonna jump to the code, okay? So inside the bubble sort here, what we're gonna do, we're gonna define 3 ig and temporary value, okay? We could not define anything actually, just we're gonna start with a for loop, and this should be an int, so we're gonna define int of I. Then this is gonna be after the size -1, and here is gonna be another loop, inner loop, and also is gonna be an int type of second loop, as I explained already, up to the size. And here we're gonna check if the array at E is greater of the array at G. If so, we need to swap these two, okay? We need to swap, what we need to swap? We need to swap the array, the I of G, okay? Like this. So let me get off this curly bracket to make the code a bit simple. Now we're gonna copy this swap function at the top here and define it. It is gonna also have the type of void. This is gonna be int int. Inside the swap, we're going to define a temporary value that catch for us the array at a position I and swap it with the array at position G. Okay, so this is how to swap element G, and finally array at G is going to be equal to the temporary value, like this. So now we're gonna run the code. So let me clear the terminal and run the code again. So as you see here, the list has been sorted in descending order. We could change that, or I think it's not changed that because we didn't start here from the I, so it should be I plus 1. So this is how the loops works, as I explained. So now, as you see, the list is, or let me clear this and run it again. Okay, so as you see, the list has been sorted well. So the smaller number is -6, 1, -1, 1, 2, 2, 3, 4, 5, and 18, 19, 45. We could make it in descending order, and that just by going to the swap function, not the swap function, in if statement, and change this symbol to this, and again it is in descending order, but we need it now to be sorted in positive part. So this is the bubble sort. Now we're gonna move to the next sort. Now we're going to create the insertion sort. So insertion to underscore insertion dot c. Again, the same text. So before starting, I'm gonna just go to the bubble sort. I'm gonna copy the text here and close this, and let me copy this. Alright, so now what we need to do, we're gonna delete this bubble sort function and also the swap, and I'm gonna go to this bubble sort again. I'm gonna name it insertion sort, insertion underscore sort, for instance, or sort like this, insertion sort. Let me use the underscore. And the same thing inside the main function, we're gonna just change the name of the function. Okay, again, we're gonna import that at the end here and pass the code this function. I'm sorry what I've copied. Yep, we should copy this. Now we are good. Okay, I'll leave you again with another little video that explains how this sort works. The second algorithm that we want to explain now, it is the insertion sort. So the insertion sort is a simple sorting algorithm that works similar to the way you sort playing cards in your hands. The array is virtually split into a sorted and an unsorted part. Values from the unsorted part are picked and placed at the correct position in the sorted part. The characteristics of insertion sorts. This algorithm is one of the simplest algorithm with simple implementation. Basically, insertion sort is efficiently for small data values. Insertion sort is adaptive in nature. Basically, insertion sort is efficiently for small data values. 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 Insertion sort is adaptive in nature. that is appropriate for data sets which are already partially sorted. Working of insertion sort algorithm. So insertion sort execution example, as you see on the screen, this little example. So we have here the first row. We have a list of numbers, or you could imagine like an array of numbers, or an array that contains different block of numbers. So 4, 3, 2, 10, 12, and 1, 5, 6. So what we're going to do in the insertion sort, we're going to compare the first two elements, 4 with the 3. So in this case we find that, or we have found that 3 is smaller than the 4. So what we're going to do, we're going to insert the 3 at the beginning and push all the elements to the right. Again, we've got 3, 4, and 2. Again, we're going to compare 2 with all the elements that exist previously. So 2 is going to compare with the 4. So, and we're going to again to compare with the 3. So 2 is smaller than the 4, smaller than the 3. So we're going to insert it before the 3 and push all the elements to the right. Okay. So we've reached now to 2, 3, 4. Then we have 10 and the rest of the array elements. So 10 is the greatest elements from 2, 3, 4. So we're going to move on to the next element, and it is 12. And 12 also it is the greater element. Now we're going to move to the next element, and it is 1. And 1, it is smaller than 12, smaller than 10, smaller than 4, smaller than 3, smaller than 2. So we're going to put it before the 2 and put the rest of the elements of the array to the right. So again we have 5. So 5, it is smaller than the 12 and it is smaller than the 10, but it is greater than the 4. So we're going to put it after 4 and before the 10. So we're going to insert it before the 10 element and push all the other element to the right. Okay, so we've got now 1, 2, 3, 4, 5, and we have 10 and 12. Now we're going to get to the number 6. 6 is smaller than the 12, and also it is smaller than the 10, but it is greater than the 5. So we're going to insert it after 5 before the 10. So we're going to insert it before the 10 and push the others to the right. So this is how the insertion algorithm work, or the insertion sort. I hope you get it well. Now we're gonna just apply what we've seen in the code. So we're going to find some ints for I and G. This is for the loops. We're going to run a loop up to the size like this. Here we're going to create a current value that catch for us the first element at this loop. So it's going to be current equal to array at A or at I. Again, we're gonna need to define this at the top. So, and we're gonna set G equal to the I minus 1. And insertion sort is better to use while loop. So we're gonna use while loop, while G greater or equal to 0, and array at G greater than the current element. Greater than the current element. What we need to do, we're gonna need to the array at G plus 1 to be equal to the array at G. Okay, and we're gonna reduce the increment the G. After that, what we're gonna do, just catch the G array at G plus 1 and set it equal to the current, like this. So let me run it again. Array after and before. Let me see, and again it's sorted well. So this is the insertion sort. The third sort we have here, it is selection sort. So selection dot c. Again, we're gonna pass this text. Let me clear the terminal, and also here I'm gonna name it selection. Okay, selection sort. I'm gonna import this function at the bottom. Like this. So again, I'm gonna leave you with another video that explained how selection sort works. Selection sort algorithm sorts an array by repeatedly finding the minimum element, considering the ascending order from unsorted part and putting it at the beginning. The algorithm maintains two subarrays in a given array: the subarray which is already sorted, remaining subarray which is unsorted. In every iteration of selection sort, the minimum element, considering ascending order, from the unsorted subarray is picked and moved to the sorted subarray. So how it works? This figure on the screen shows the bubble, or I'm sorry, it shows the selection sort. So as you see in the first table here, imagine this is an array of elements. So we have 20, 12, 10, 15, then 2. We're going to compare the first element with the next element. So 20 with the 12. Here we're going to find that 12 is smaller than the 20. So we're going to select them both and swap them. Then we're going to get 12, 20, 10, 15, 2. Again, we're going to compare the first element with the third element. In this time, we're not going to compare with the second element, but we're going to compare it with the third element. So 12 with the 10. Here we're going to see that the 12 is smaller than, greater than the 10. So we're going to select these both numbers and swap them. So we're going to have 10, 20, 12. Again, we're going to select the first element with the fourth element and compare them. In this case, we find that 15 greater than the 10, so we're going to change nothing. Again, we're going to compare the first element with the last element. In this case, 2 is smaller than the 2, so we're going to select these both elements and exchange their places or swap their places. So this is the step 1. Secondary step, we're going to compare the second element in the array. So in this case, the first element in each step, an element catches position. So 2, it is in its right position and not going to change it anymore. Again, now the sorted array, the unsorted array, it is from 20 to the rest of the array on the right, and the 2, it is the sorted part of the array. Again, we're going to compare the 20 with the 12. Again, exchange their places. The same thing, 12, the second index or the second place, compare with the third place or the fourth place in the table. Again, here we're going to find that the 15 is already greater than the 12, so nothing can happen to this table in this case. Again, we're going to compare 12 with the last element, and the last element, it is 10, and it is smaller than the 12, so we're going to swap these two or exchange their places. Select them both, then exchanging them. So in the step 2, we're going to find that the last sorted array, it is from 10 to the left, and unsorted array from 20 to the right. Again, we're going to start from 20 comparing. So 20 with the 15, swap them, then 15 with the 12, swap them. We're going to get 2, 10, 12. This from 12 to the left are sorted array, and from 20 to the right are unsorted array. Again, compare these both, 20 and 15. We find that 15 is smaller than the 20. I'm going to exchange their places or swap them. So this is how selection sort works. I hope you understand and get it well. So selection sorts, we're gonna again to run a for loop inside the function, and let me up to the size, of course, size -1, and here we're gonna define the I and also the G for the loops. Inside of here, we're gonna catch a value that catch the min value in the array. So min is gonna be equal to the first element here, or the first index I. Then we're gonna again run a for loop and see from the G equal I plus 1 up to the size, like this. What we're gonna do here, we're gonna check if the array at index min is greater than the array at G. If so, we're gonna let the min take G instead of I, like this. Let me reduce this curly bracket to show the code well. Okay, like this. So here, if the min not equal to the I, that basically we're gonna swap them again as we've done before using temporary value of the array at E. Array at E is gonna be equal the array at G, the min, and the array at min is gonna be equal to the temp. And again, let me define this temp at the top here. So let me run the selection sort and see, and again it sorted well. So this is how to apply the selection sort in C language. Now, after ending with the bubble and insertion and selection sorts and explain them how they work, we are going to jump to the recursion functions. So if you don't know what recursion function is, so the recursion function is a function that calls itself. I really recommend you to take a look at the course that I made about C language. So there, a recursion function explained where. Well, just a cover idea, a recursion function that calls itself. So here, what I'm gonna do, just gonna copy this bubble sort. I'm gonna put it inside the bubble sort recursion, like this. What I'm gonna do, I'm gonna change the name of the bubble sort to what? To bubble underscore recursion, like this, recursion. After that, we're gonna remove this inside the recursion, and the swap function, I'm gonna just leave it now. Okay, so the recursion, what we're gonna do, we're gonna try to bring a method that's going to let us call the function itself inside of the function itself, basically. So we're gonna just do like an if statement. If the size greater or equal to the 0, what you're gonna do, we're gonna run a for loop of I or anything, but let me here do the G better, the G for instance, up to the size -1. Okay, we're gonna check here if array at G is greater than the array at the next position, and it is G plus 1, like this. What you're gonna do, we're gonna swap them. Swap what? Swap the array at G. So like this. So now we have just we have only one parameter. So we're gonna remove this, and the I is gonna be changed to G, and the G is gonna be changed to G plus 1, like this. Now, after doing this, we're gonna call the function. It's called itself each time. So return bubble underscore recursion with the array, of course, and the size -1 to let reach position 0 and then stop the loop and get out of it. So let me run it now and see. So if statement, there is something wrong in if, that because I don't know, but yep. Now let me run it again. Here it is. So it sorted well using bubble recursion. So we're not going to jump to the next method of sorting. Now we're gonna do the insertion sort in recursion. Again, I'm gonna copy the text that we've created already in insertion sort. I'm gonna create another file called o5 underscore insertion underscore recursion dot c and pass the text here. Okay. All I'm gonna do, I'm gonna change the name of the function to what? To insertion. So insertion, instead of sorts, I'm gonna do recursion like this. So now I'm gonna just edit inside the insertion sort recursion. So what I'm gonna do, I'm gonna delete everything here and try to bring a method that let us call the function itself. So here, instead of current, I'm just gonna make the last number. Okay, so I'm gonna again do an if statement. If the size smaller or equal to 1, what you're gonna do, you're gonna just return and do nothing. That means the function's end. Then insertion sort recursion call the function itself with the array and the size -1. Then we're gonna set the last to the array at size -1. Okay, and a G to the size -2 to the previous position. So now we're gonna create another while G is greater or equal to 0 and the array at G is greater than the last. What you're gonna do, you're gonna set as array at G plus 1 to the G to the array at G and decrement the G. After that, just set this array here to last like this. I hope everything is clear. So let me run it on the terminal, and here it is, works well. So now we're gonna move to the next recursion source. Now we're gonna do the selection in recursion. Again, we're gonna move to the selection source, copy the text here, delete it, add another file called o6 underscore selection underscore recursion dot c, pass the text. Here we are. Let me change the name of the function to recursion selection recursion. Again, inside the selection recursion, I'm gonna delete everything. I'll leave only the first line. Okay, so inside of the main now, we're gonna use the location to catch the location instead of the main location. Now here, we're gonna say, and the selection recursion, we're gonna give it two, not only two parameters, we're gonna give it another parameter. So this parameter, we're gonna call it the start, like this. And this start in the main function here, inside of the main function, is gonna be the position 0. And here also is gonna has the name of start, like this. Alright, we're gonna check if start greater or equal to the size. So here we're gonna like incrementing. What we're gonna do, we're gonna just return like this. we're gonna set the location to the start and run a for loop of I starting from the start plus 1 up to the size. Let me add this space there like this. Alright, let me delete this part of the code and add an if statement. If array at location what is greater than the array at e. What we're gonna do, we're gonna set the location takes that index I. Let me remove this bracket, or just let me leave them later. Okay, so out of the loop we're gonna do an if statement and check if the location not equal to the start. If so, we're gonna create we're gonna swap them basically. So the temporary value with the array at start is gonna be equal, so array at start is gonna be equal to the array at location, and array at location is gonna be equal to the temp. So this is the swap. After that, we're gonna just return the function return what selection recursion with the array and the start plus 1. So here incrementing, and the size is gonna be the same like this. So let me get it out this lot of brackets like this. Now it is clear. So this is how the selection recursion. Let me run it, and as you see, the array has been sorted well. Now we're gonna move to the next final 3 sorts. Now we have completed this most important algorithm, or the most important sorts. There are 6, basically just 3, but the other 3 is just the recursion functions of them. So the 7 sort, it is the odd even sorting. So odd even sorts.c. So basically to understand how it works, I'm gonna leave you again with another video, a small little video that explains how this odd even sorting works. Odd even sort or brick sort. This is basically a variation of bubble sort. This algorithm is divided into 2 phases, odd and even phase. The algorithm runs until the array elements are sorted, and in each iteration 2 phases occurs, odd and even phases. In the odd phase, we perform a bubble sort on the odd indexed element, and in the even phase, we perform a bubble sort on the even or on even indexed elements. This figure explained well what's going in the background. So imagine we have here this unsorted array 2, 1, 4, 9, 5, 3, 6, 10, some random numbers. In the step 1, we're going to start odd. So when we say odd, it's starting from the first, these both elements, okay, 2 elements, comparing them. So if these 2, if 1 is greater than if 2 is greater than the 1, we need to swap their places, or to swap them. So we're going to get 1, 2. Here we have 4 smaller than the 9, so nothing can happen. Again, we have 5 smaller than greater than the 3. We're going to change their places, and we're going to get 3 and 5 in the results of step number 2. Imagine here, when we say step 1, the result of step 1, it is step 2, and the result of step 2, it is step 3. Okay, so in each part we're computing the two numbers. If we find the smaller number at the end, we're going to swap them. So 6, it is smaller on the 10, nothing gonna happen. So in the step 2 and the result step 3, so we're here even, we're gonna start with the even indexes. So 1, we're not going to touch number 1 because it is at odd position, but 2 and 4, or the 2, it is at even position, so we're going to compute 2 with the 4. 2, it is already smaller with the 4, and nothing can happen. And 9, it is greater than the 3, so we're going to change them, and we're going to see that the result in the step 3 becomes 3 than 9. 4, 5 and 6 already in the places, nothing gonna happen. So in the step 3 again, so like this how this odd even sorting works. So the rest is just gonna be like this, comparing starting from the odd index or odd position, then comparing two elements by two elements. Again, we're going to see the result in even position, and again comparing two elements by two elements. And the result at the end, at the step 8, we're going to find that the array has been sorted well. So this is the odd even sorting. I hope you understand the basics of this. I hope you understand how this sorts or this sort works. So now what we're gonna do, just start coding or applying it in this language C, of course. So inside the int main function, so better I'm gonna go to the bubble sorts. I'm gonna just copy everything here. Again, I'm gonna go back to here, pass it. I'm gonna remove the swap function, and again I'm gonna rename the functions or the function bubble sort to odd underscore even underscore sorts. Okay, now inside the odd even sorts function, I'm gonna define something here. So the I and the D are for the loops. I'm gonna add another flag, okay, and another temporary value in the flag. So we're gonna do a while loop inside this one here, inside the code and inside the condition. We're gonna just say while flag it is equal exactly to 1, do this process here. So we're gonna start the flag equal to 0. Okay, so now we're gonna do even sort. So even sorting like this. So we're gonna create a for loop from up to the size -1, and we're gonna increment it by 2. Okay, again we're gonna just check here if the array at E or at I is greater than the array at I plus 1. If so, what are you gonna do? Just swap the array at E with the array at I plus 1. I'm sorry, I spell I E. It's I, not A. I'm sorry. So the temp here is gonna be equal to the array at I, index I, and the array at index I is gonna be equal to the array at index I plus 1, and the array at I plus 1 is gonna be equal to the temp. So this is how to swap basically. So this is array. Now after doing this, we're gonna set the flag equal to 1 to repeat the process until this condition get off. Okay, so this is for sorting the event. So if I here run the code, so let me clear and run the code. So as you see, the numbers that exist at the event position has been sorted. Let me see, it's not. I'm sorry, it's not. let me complete the code. I think when we complete it, it's gonna be sorted. Okay, now for odd sorting, even odd, so odd. Okay, the same process actually here. We need this loop like this, the same thing, just instead of here starting from 1, here it's gonna be started from here started from 0, here it's gonna be started from 1, and also everything is gonna be the same, nothing is gonna be changed. So let me run it to see. So now the code works well. It's clear, the array sorted well, as you see, -6, -1, 1, 2, 2, 2, 3, 4, 5, 18, 16, 18, 19, and 45. So this is how to do the odd and even sort in C language, or how it works basically. Now we're gonna move now to the next method of sorting. The next sort that we're gonna see, it is the merge sort. So I'm gonna create a folder here called op8 underscore merge.c start code, and here is gonna pass the code of this merge sort. So before I'm gonna start the merge sort, I'm gonna leave you with a little video that explains what is the merge sort, and then we're going to be back to the code. Merge sort algorithm is a sorting algorithm that is considered an example of the divide and conquer strategy. So, in this algorithm, the array is initially divided into two equal halves, and then they are combined in a sorted manner. We can think of it as a recursive algorithm that continuously splits the array in half until it cannot be further divided. This means that if the array becomes empty or has only one element left, the dividing will stop. That is the base case to stop the recursion. If the array has multiple elements, we split the array into halves and recursively invoke the merge sort on each of the halves. Finally, when both the halves are sorted, the merge operation is applied. Merge operation is the process of taking two smaller sorted arrays and combining them to eventually make a large one. So I'll give you some basics of this before getting to the code. I'm gonna give you what we're going to do. So declare left variable to 0 and right variable to n-1, like saying declaring the starting point from 0 up to the final point, or the height of the array to n-1. N it is the length of the array minus 1. In the cursor, we're going to use size instead of n or length, so it's gonna be size minus 1. Second thing, find mid by median formula, mid equal left plus right on 2, and in the code we're going to discover a new equation better to use instead of this. Third, call merge sort on left mid, call merge sort on mid plus 1, then the rear. Continue till left is less than the right. The call merge function to perform merge sort. So this is the steps. Now this figure here shows well what is happening in the background. So this is unsorted array that contains 8 numbers. So we divided this array into 2 subarrays, and each subarray we're going to divide it into 2 subarrays. So we have again here like a small array of 4 elements. We're going to divide it again, so we're going to get again another array or subarray with 2 elements. These 2 elements, we're going to compare them. As you see here, we find that 7 smaller than 3, we're going to swap them. The same thing for this 2 and 16. We're gonna nothing happened because 2 is already smaller than the 16. So we're going to merge these numbers or these subarrays into a sorted array. The same thing for the right subarray. The same process happens there. And finally, we merged the both sorted arrays into main array. So this is how the merge sort works. I hope you understand the algorithm of the merge sort. So what we're going to do now is just going to apply it in this beautiful language. So I'm gonna go to the Babel sort or any sort here. I'm gonna just copy the syntax or the code. I'm gonna go back to the merge sort and pass it here. So what I'm gonna do inside of the Babel sort, I'm gonna remove the code inside this function. I'm gonna return the bracket. I'm gonna remove this swap function, and the others I'm just going to leave them as they are. So I'm gonna just now remove, or instead of Babel sort, I'm gonna change it to merge sort like this, or underscore sort. So like this better, as I think, merge sort. So I'm gonna go to this merge sort here, and as I explained already, it's not going to have only one parameter, it's going to have two parameters. So it's going to have like the L, low, and another parameter, I'm going to call it R. So we're going to jump to the main function here and change these parameters. So the array is going to be the same, we're not going to remove the array or anything, but in the size, it's going to be starting from 0 up to the size -1. So this is the parameters that we need to pass. So we're going to go at the top here to the merge sort function, and also change this. I'm gonna do L and int R, as I've done here at the bottom. Okay. So now what we're going to do? So we're going to check if the L smaller than the R. So if this smaller than the R, basically like we're seeing if 0 are smaller than the size -1, but the 0 is going to be incrementing as we're going to say. Okay. So if L smaller than the R, what we're going to do? We're going to define an int m and letter to be equal to L plus R minus L, then divided on 2, like this. So if you didn't understand what I've done here, so it's like basically doing L plus R all divided in 2. So all divided and 2. So let me do, so like this. So this expression, basically it is equal to this expression. They are the same. So this expression, let me remove the m, this expression are equal to this expression. Just we type this expression to avoid overflow for large low and on the height, of course. So this is the same expression. If you are already familiar with the binary search, in the binary search we could do this and we could do this, are the same. They are the same. Just this it is better for equations or large numbers, and this is kind of gonna be an overflow for something like. So just do not get confused here. These two are the same expressions, okay? But better to use this expression. All right. So we're going to find this as I said, and we're going to sort the first and second halves, okay? So what we're going to do, we're going to recall this function recursively. So merge sort, and we're going to open bracket, parentheses, and pass the array name, and we're going to pass L and M, okay? Like we're sorting half by half. Again, we're gonna call the merge sort array and m plus 1 and the r, like this. After that, we're going to need to call another function that we're going to create, okay? And this function we could call it, for instance, merge, and pass inside of it array and the l and the m and the r, like 4 parameters here. So I'm gonna copy this function. I'll go at the top here. I'm gonna pass it. So this function also is going to have this the type of void, okay, void, and this is are all integers, like this. All right. So the role of this merge function is to merge the two sub arrays of the array of the main array of this array, okay? So inside of this function we're going to define like I, G and Q, or key, and then we're going to pass 2 in 1 and in 2. So basically when I say in 1 and in 2, they are just the length for of the two halves of the array. So like this main array, we're gonna divide it to two sub arrays, and each array is gonna contain the half of the array. So each half, it has a length, a separate length, okay? So in 1 is gonna be m minus l plus 1, clear? And for the length 2 is gonna be r minus m. All right. Now what we're going to do, we're going to create the temporary array. So create temp arrays, like this. So we're going to define ints. We're going to call the first one L. I'm going to pass inside of it in 1, and the second one, it has the length 2 in 2, like this. Now what we're going to do, we need to copy that data to the temporary array L and R, okay? So we need to copy this data. Let me comment here, copy data to temp arrays. These are the temp arrays. What we need to do now, we're gonna just create a for loop. Let me delete this comment here. I'll say L at E or at I is going to be equal to the array, main array, at L plus E. Clear. Okay, of course here is going to be the in1 because we are working with just this length of the array. The same thing for the second array, and just some equations is going to be separately different. So here is going to be R. I'm sorry, here is going to be R. And at the array, not at L plus I, but it's going to be M plus 1 plus G. So M plus 1 plus G. So like this. So now we're going to merge these two arrays in the main array. So like, let me comment this, merge the temp arrays back into main array, or array L up to the R, okay, like this. So we're going to set I equal to 0 and G equal also to 0 and key equal to L. So this I equals 0 initial index of first sub array, and for the G it is for the second array sub array, of course, and the third one it is for the merge sub array. So we could like count it here, initial like this, index of first subarray subarray like this. Let me copy this, and this is gonna be second, and this is gonna be merged like this. So what we're going to do now, we're going to create a while loop. So we're going to say while I smaller than the first length in 1 and g smaller than the second length. What we need to do here, we need to say the array at key, or before this we need to check if the array or the subarray L at E smaller or equal to the array or subarray at G. If so, we're going to set the array at key equal to the L at E. Then we're going to increment the I like this. Otherwise, else, what you're going to do, we're going to make this one, the difference is going to be here G, of course, and the array at key is going to be R at G instead of I at G. Okay, so now we will copy the remaining elements of L if there are any. Okay, so we're gonna go here and say copy the remaining elements of array L if there are any. So better to change multiple line like this. So let me make this a bit smaller to the left or to the right. Alright, we're going to create another while loop and say while I it is smaller than the first length. What we're going to do, we're going to do this. Let me just copy this and pass it here, and this is going to be L, and this is going to be, instead of G, it's going to be I, and we're going to increment the I and also increment the key like this. And the same thing for the sub array or for the array R. So the same thing. Just all you have to do, just copy this, pass it here. We're gonna say R, and this is gonna be G smaller than in 2, and here it's gonna be R, and here G, and here we're gonna increment the G instead of the I. So up to now I think everything is good. Everything is correct. So now all we have to do is just to run the program and see if this merge sort works perfectly. So it doesn't work. It just printed me the first array without sorting it, and that because there is something wrong in the merge function. So copy data to temp array. Yep, here we need to change this to G instead of I, and also here to 2 instead of 1, and also here to G. Okay, let me see if I forget something here. And of course we need to increment the key here inside of the loop, so key ++, and I think should be run well now. So here it is. So the code is working now perfectly. So -6, -1, 1, 2, 2, 3, 4, 5, and 18, 19, and 45. So the merge sort now is working perfectly. I hope you get the code, and I hope you get the basics or the fundamental of this merge sort. Thank you for watching. Let's move on now to the quick sort. Now we have reached the last method sorting in this tutorial, and it is the quick sort. So again, I'm going to create another file and I name it quick underscore or underscore with underscore sorts. Of course, I need to add the extension .c at the end, and I'm going to jump again to the bubble sort. I'm gonna copy this code, all of it, and I'm gonna pass it inside of the quick sort. Again, I'm gonna remove the code inside of here, and also I'm gonna remove this swap function. I'll go at the top here, and I'll start renaming this bubble sort to quick sorts underscore sort, like this. So basically here the quick sort is also has more than it's like the merge sort has more than 2 parameters. So before we're gonna deep in the parameters and all of this stuff, I'd really recommend you to keep watching the explanation or the understanding of this quick sorts, and then it's going to find the code here as you used to. The quick sort. The quick sort is like merge sort. Quick sort is a divider and conquer algorithm. It picks an element as a pivot and partitions the given array around a big pivot. There are many different versions of quick sort that pick pivot in different ways. So there is some steps here. Always, or conditions, always pick the first element as a pivot, and always pick the last element as a pivot, and pick a random element as a pivot, or pick medium as the pivot. The key process in quick sort is a partition. The target of partitions is given an array and an element x of an array as the pivot. Put x at its correct position in sorted array, and put all smaller elements smaller than x, of course, before x, and put all greater elements greater than x after x. All this should be done in linear time. I think that this figure is going to help you to understand the quick sort, but for me, I'm going to show you a video or a small part how the quick sort actually works. It is quite understandable for me, so I'll leave you with this small video to see it, and then we're going right away to jump to the code. Now, after explaining the quick sort how it works, what we need to do is just apply it in this beautiful language as always, and run the code or execute the code, and then end this video. Alright, so the quick sort the quick sort part. What we're going to do inside of this quick sort, as I said at the beginning, this is not going to have only one parameter, but it's going to has multiple parameters. So inside of the main function, what we're gonna do, we're gonna leave the array as it is, but inside of size we're going to pass 0 and the n minus 1, or the length of the array minus 1, and it is basically size minus 1. So inside of the quick sort here, what we need to do here is just printing like name it low as soon as starting point, basically up to the height, or up to the high, and it is the height of the size, basically. So if the low smaller than the high, what we need to do, we need to create int, I call it p or the pi, and set it equal to partition function, and this function is going to have the array and the low as parameters, and the low and the high. Okay, and then we're gonna call the quick sort recursively, like this. So the quick sort, we need basically remove all of this int part and remove this part for the array, and we're going to start from the low up to the pi minus 1, up to the pi minus 1, and this another one here up to the high from the pi plus 1, like this. So now we need to create the partition function. So we're gonna just copy this function here. I go at the top and pass the function. So this function is going to has the integer type, and we're gonna name these things here to the int and pass here the name of the array. Open the function. So we're gonna create int and call it pivot equal to the array at the height, like this, and then creates another integer called I and set it equal to the low minus 1. So the low subtract out of it 1. Then run another for loop for int. I call this G instead of I, and the count is going to be the height or the high. Okay, and we're gonna here check if the array at G is smaller or equal to the pivot. So if array at G is smaller or equal to the pivot, exactly like this, what we're going to do, we're going to increment the I and swap using swap function. I'm gonna use the addresses here. I'm gonna use array, or using pointers basically, I with another one, array at G, array at G, like this. So again, out of this for loop, what we're going to do, we need to recall this swap function here, but instead of I, it's gonna I plus 1, and G is gonna be the height or the high as we define it. And after that, we're going to return I plus 1, like this. So basically everything now is correct, but we need to redefine this function, swap function, and the swap function is gonna has void type because it returns nothing. And here we're going to create a temp like this and set it equal to the pointer A, and I'm gonna remove this top here. I'm gonna just name it int pointer A, and this is gonna be B. Alright, here A, and pointer A is gonna be equal pointer B, and pointer B is gonna be equal to the temp, like this. So now, as I think that the code should be work well fine. So let me run the code and quick sort. Something wrong has been happened here, and that because at the top here we didn't make anything to the definition of the function at the top. So I'm gonna copy this line of code. I'm gonna go at the top of the function here and like this. So let me re-clear this and run it again, and it's still not working. And it's not working because I don't know, but probably we've made something wrong in this partition part. So we've make the pivot equal to the array at high, and we set it equal to the low minus 1, and we set int. So basically here it should not start from the 0 but should start from 1 as soon as we're using the function recursively. So is the low is going to be changing each time. So let me run it again. So here it is. The numbers has been sorted well. So this is how to do the quick sort, or how to apply it in C language. I hope you have fun while you're learning, and thank you for watching, and see you for the next tutorials.